to another tutorial for the Edexcel Further Pure 1 Maths course. This is the second video on matrices. As always, for more help with your maths studies, do see the YouTube channel or website. We all start by looking at the specification, and here it is. In the first video we added and subtracted matrices, and we also multiplied a matrix by a scalar, which was just a number, and in this video we're going to work out the product of matrices. We are going to times one matrix by another, or multiply one matrix by another. Okay, to start with, I would like you to have a guess what you think the answer would be to the following matrix multiplication. Now, did you write down the following? I would have guessed that you would have written down the following. You'd have written 2 times minus 1 is negative 2, sorry, negative 1 times 4 is negative 4, 0 times 5 is 0, and 3 times 3 is 9. I'm sure you would have written that down. Unfortunately, that isn't the right answer. Matrix multiplication is slightly more complicated. How about I give you the answer and see if you can reverse engineer it? What method is going on to get this answer? That's the answer to the problem. Okay, well, maybe you've had a thought about that, maybe you've been able to work it out, but let me show you what's going on, and this is how matrix multiplication works. Okay, if I'm trying to work this out, what I do is as follows. I take the elements of the row of the first column and I multiply it by the elements of the so I take the elements of the row of the first matrix and I multiply it by the elements of the column of the second matrix. So I do 2 multiplied by negative 1, and then I add negative 1 times 5. Okay, then to do this, the next one over here, I do 2 and negative 1 multiplied by 4 and 3. So I would do, for this one here, I would do 2 multiplied by 4 plus negative 1 times 3. To get this element here, I do 0 and 3 and I multiply it by negative 1 and 5. So I do 0 times negative 1 and I add 3 times 5. And the last one, I do 0 times 3, 0 and 3 multiplied by 4 and 3. So I do 0 times 4 plus 3 times 3. Okay, now if I actually go ahead and work that out, 2 times negative 1 is negative 2, and then add negative 5, I get negative 7. 2 times 4 is 8, negative 1 times 3 is negative 3, 8 and negative 3 is 5. 0 times negative 1 is 0, 3 times 5 is 15, 0 times 4 is 0, 3 times 3 is 9. Okay, so let's just to summarize that again to get each element. To get the top left-hand corner element, I do the top row, the first row times the first column. To do the top right-hand corner element, I do first row multiplied by second column, and that gets me this one. To get the bottom left element, I do the bottom row times the first column. And then to get the bottom right element, I do the bottom row times the second column. Okay, hopefully you've got some intuition how this might work, and I'll go into slightly more detail in a second, but just at this stage, maybe you take a go, using what I've done above, of working out the following. Could you try for me to work out this matrix multiplication? And see if you can work that one out for me. Well, I'll go through this. Okay, I would do negative 1 times, so let's just, I would do that, I'm multiplying that by that. So I would do -1 times 2 plus 4 times 0. The next one, I would do -1 and 4 multiplied by -1 and 3. So I do -1 times -1 plus 4 times 3. To get the bottom ones, I would do 5 and 3 multiplied by 2 and 0. So I would do 5 times 2 plus 3 times 0. And to get the last one, I would do 5 and 3 multiplied by -1 and 3. So I would do 5 times -1 plus 3 times 3. Okay, I'm working these out. What would I get? That's -2 add 0 is -2. That's 1 add 12, which is 13. That's 10 add 0, which is 10. And that's -5 and 9, which is 4. And I get the following. Okay, the reason I showed this, just out of interest, these two matrices involved in this multiplication are the same as these two, but I've just swapped them round. And I can see that if I multiply a matrix, say A times B, I don't always get the same answer if I swap around the A and B. It's not like numbers. 2 times 3 is the same as 3 times 2 in numbers, but A times B is not necessarily the same as B times A in matrices. Okay, next one. Why don't you try this one? Can you have a go at that one for us? Right, let's have a go. Remember here to have a go at it. That times that multiplied by those. So I would get myself 1 times 1 plus 0 times 2. Okay, and I've done everything now in the top row. There's nothing else to multiply. And for the bottom one, I would do that multiplied by that. So I would do -1 times 1 plus 3 times 2. And I get the answer. 1 times 1 is 1 plus 0, so I get 1, and I get -1 times 1 is -1 plus 6, I would get 5. Now this is very interesting here. The matrices don't have to be the same order or dimension to multiply them. All you need to make sure is you've got the same number of elements in a row as the elements in the column. Another way of saying that is I have the same number of columns, 2 columns, in the first matrix and 2 rows in the second. That way there's enough elements to times by each other. Okay, why don't we finish off with you having a go at this one here. Well, can you do this one? Well, actually, no, I put that one in on purpose. This one's not doable because you have to take all the elements of the row and multiply it by the elements of the column. But I've got 3 elements here and I've only got 2 elements here. So I don't have an element down here to multiply by the 4. So I can't do this one. It's not possible. The only way I can do a matrix multiplication is if the number of columns in the first matrix equals the number of rows in the second. That's the only way I'm able to do that. Okay, let's formalize this now with talking through some strict definitions. So, to multiply matrices, you take the elements in a row of the left-hand matrix and multiply them by each element in a column of the right-hand matrix, and you add the answers. So, as an example, I'm not going to do every type of matrix, but if you've got the matrix A, B, C, and D, a 2 by 2 matrix, and you're multiplying it by, let's say, a matrix E, F, G, and H, what would you get? Well, it's that row times that column, so you would get AE plus BG. That row times that column for over here, you would get AF plus BH. The second row times the first column, so you get CE plus DG, and you would do that second row times the second column, and you would get CF plus DH. And that's in general how you do it. And you can do it for different size matrices, 3 by 3s, 1 by 3s, etc. However, in order to be able to multiply matrices together, the number of columns in the first, okay, the number of columns here, there was 1, 2 columns, must be the same as the number of rows in the second. There was 1, 2 rows here, and it worked. Otherwise, you can't. If the number of columns in the first is not the same as the rows in the second, you can't multiply. So let's say we were having a matrix A and we were multiplying it by B. And this gives us an answer, C. We're able to do it. Say matrix A was an n by m matrix. Let's say, for example, let's say a 4 by 3 matrix. And matrix B, in order to do the multiplication, the number, remember, really confusing, okay, the second is the number of columns, okay, so we want the number of columns in the first to equal the number of rows in the second. So this number here must be the same as this number. This is the columns in the first and the rows in the second. So if we multiply this by, say, a 3 times 5 matrix, because the number of rows, of columns in the second is the same as the number of rows, because the number of columns in the first is the same as the number of rows in the second, we can multiply these and we end up getting a 4 by 5 matrix as our answer. So you can only multiply matrices if the number of columns in the left-hand matrix is the same as the number of rows in the right-hand matrix. And one thing we notice as well, in general, A multiplied by B was not the same as B multiplied by A. And that's to say, the mathematical way of saying that is matrix multiplication is not commutative. Okay? And the order in which we multiply is important. So those are the key elements we've learned from the previous example. Now it's time to do a few exam style questions that come up. I would encourage you to have a go at these before watching me, because they're all fairly straightforward. So pause the video, have a go, then check your answers against mine. Right, we're working at A multiplied by B, so we're doing 1, 3, negative 2, 4, and we're multiplying this by negative 3, 2. Let's just always, I think it's good practice to just do the orders as we go along. So we're doing a 2 by 2 matrix, okay, 2 rows by 2 columns, and we're multiplying it by a 2 by 1 matrix. Because that number and that number are the same, we can do this, and we know we're going to get a 2 by 1 matrix answer. This helps us do these problems. Okay, let's just go ahead and do it then. Why don't we do that row times that column, and what would we get? Well, we'd get 1 times negative 3 plus negative 2 times 2, and then you would do that times that, and you would get 3 times negative 3 plus 4 times 2. And working it out, what would you get? That's negative 3 and negative 4, so that's negative 7, and you get negative 9, add 8, and you get negative 1. And hence that's your answer. And you have a 2 by 1 at the end, which you were hoping for and which you knew you were expecting. So it gives you some sense that you've actually done the question correctly. Very good. Next example, pause the video, have a go yourself, then watch me. Okay, first we're working out AB. So what we're doing in part A, we're working out negative 1, 0, 2 and 3, and we're multiplying it by 4, 1, 0, negative 2. Okay, so what we're going to do, I'm going to start doing these in my head now. I'm going to do that times that. Just before I do that, I'm doing a 2 by 2 multiplied by a 2 by 2, because the number of columns in the first is the same as the rows in the second. I can do it, and I know I'm going to get myself a 2 by 2 answer at the end. I'm going to get myself a 2 by 2. Right, I'm going to start doing these in my head now. negative 1 times 4 is negative 4, 0 times 0 is 0, so that's negative 4. This one over here, I'm going to do that times that, so I'm going to get myself negative 1 times 1 is negative 1, 0 times negative 2 is 0, so I'm going to get myself negative 1. Then I'm going to go that times that, and I'm going to get myself 2 times 4 is 8, 3 times 0 is 0, so I'm going to get 8. And lastly, I'm going to do that times that, and I'm going to get 2. 2 times 1 is 2, 3 times negative 2 is negative 6, 2 and negative 6 is negative 4. And my answer, therefore, is 4, negative 1, 8 and negative 4. Okay, B, we're doing BA. So we're doing B first, and we're multiplying that by A. So B's on the left-hand side. We're doing 4, 1, 0, negative 2, and we multiply this by negative 1, 0, 2 and 3. Okay, as always, we do a double check. We're doing a 2 by 2 multiplied by a 2 by 2, because the number of columns in the first is the same as the number of rows in the second. We can do it, and we're going to get ourselves an answer of a 2 by 2 at the end. I'm just going to straight away write these. I can get good at doing these in my head. That times that and that times that. Negative 4 and 2 is negative 2. 0 and 3 is 3. 0 and negative 4 and negative 6. Hopefully you would have got that answer working through it. And just to note, as we talked about previously, AB is not the same as BA. They give you different answers. Matrix multiplication is not commutative. Okay, next example. Pause the video, have a go yourself. Right, here we're given 3 different matrices, and we're asked to work out various products or multiplications of matrices, and in some cases you can't work them out. Now AB, let's just think of AB before we launch into AB. AB, what type of matrix is that? Well, really confusing. Remember, really confusing. How many rows? It's a 1 times 3, and we're multiplying that by a 1 row 1 by 2. Okay, because that number and that number are not the same, okay, i.e. the number of columns in the first is not the same as the number of rows in the second, you can't do it. So this can't be done, can't do. Okay, so there is no answer to the first one. Okay, B, can we do B times C? Well, let's just check we can. B is a 1 by 2 matrix, and we're multiplying it by C, which is a 2 by 1. Can we do that? Well, yes, that number and that number are the same, so we can, and we're going to get ourselves a 1 by 1 answer at the end. So let's go ahead and do it, B times C. We're doing 3, negative 2, and we'll multiply that by 4 and 5. Okay, so 3 times 4 is 12, and negative 2 times 5 is negative 10, so 12 and negative 10 is just 2, and we get a 1 by 1. Okay, C, can we do C? Well, what we're doing is A times C. So A is a 1 by 3, and we're multiplying that by C, which is a 2 by 1. Because the number of columns in the first is not the same as the number of rows in the second, we can't do this one. It's not possible, so we just write can't do. Okay, D and E finally, let's just finish off. Should be quite straightforward. Let's do D. We're doing for D C times A. Well, C is a 2 by 1, and we're multiplying that by A, which is a 1 by 3. That number and that number are the same, so we can definitely do this one, and we're going to get ourselves a 2 by 3 answer. Okay, let's go ahead and do this one then. So we're doing C times A, so we're doing 4, 5 multiplied by 1, negative 1 and 2. Okay, the row times the column. So 4 times 1 is 4. That goes up here. The row times the column. 4 times negative 1 is negative 4. The row times the column. 4 times 2 is 8. Then we move to this one. 5 times 1 is 5. 5 times negative 1 is negative 5. And 5 times 2 is 10. And we're done. And we do have a 2 by 3 matrix, is what we thought we were going to have. And so we're done. And lastly, BCA. BCA. Now, with something like BCA, you could first of all, let's say, work out CA, and then you could times it by B, do B times that, or you could work out BC, and you could get that answer, and you could multiply that on the with that on the left-hand side by A, whatever you think is easiest for you. Now, do we have the answers to any of these? Well, BC, looking at part B, we had BC, and BC was the matrix 2. So this is the same thing, okay, as let's do it here, as the matrix 2 multiplied by the matrix A, and the matrix A is 1, minus 1, and 2. Okay, now that's a 1 by 1 multiplied by a 1 by 3. So we can do it because you have 1 times 1, and we're going to get a 1 by 3 answer. So 2 times 1 is 2, 2 times negative 2 is negative 2, and 2 times 2 is 4. And we're going to get ourselves that as our final answer, a 1 by 3 matrix, and we're done. Okay, and lastly, example 4, just a bit more thinking involved, but pause the video, have a go, and I'll go through in 5 seconds. Okay, we are told that if I multiply B by A, I get the 0 matrix, the 1 by 1 0 matrix. Okay, and it says find AB in terms of A. Right, let's just follow our nose. Let's do this here. Let's just check we can do it. A is a 2 by 1, and I'm going to multiply it by B, which is a 1 by 2. They're the same, so I'm going to get a, sorry, that's A and B. So for A and B, for A times B, I'm going to get a 2 by 2 matrix. That's what I'm expecting. What about with BA? If I did B times A, so I'm doing a 1 times 2 times a 2 by 1. That and that are the same, so I'm going to get a 1 by 1 answer, which I'm told I get 0. So let's go ahead and work out BA. B is B and 2, and we're multiplying that by negative 1 and A. So we're going to get, for that, negative B plus 2A. That's going to be the element, and we're told that is equal to 0. Okay, so therefore, negative B plus 2A is equal to 0, and therefore we can deduce from that that 2A is equal to B. So we know that 2A is equal to B. Also, therefore, we know that A is equal to B over 2. Alright? Now, we are asked to find the matrix AB. The matrix AB would be as follows. It would be negative 1A multiplied by B2. Okay, so it would be minus 1 times B is minus B. Minus 1 times 2 is minus 2. A times B, which would be AB, and A times 2, which would be 2A. Okay, but it asks us for the matrix totally in terms of A only, so it doesn't want any B's in there. Well, we know that B is equal to 2A, so this would be negative 2A, just subbing B for 2A, be negative 2. A times B, well, B is 2A, so A times 2A is 2A squared, and the 2A is fine over here. And hence our final answer would be negative 2A, negative 2, 2A squared, and 2A, and we're done. And that's all. Okay, so in this video we've learned how to multiply matrices. You can multiply matrices of different sizes as long as the number of columns in the left-hand matrix is the same as the number of rows in the right-hand matrix. The order in which you multiply matrices is important. AB does not generally equal BA, and we've learnt the way to actually multiply the matrices. Not as easy as we would have thought or hoped, but quite straightforward nevertheless. And to finish with, I suggest you read chapter 4, 77 to 82 in the book, do exercise 4C, all the questions on page 81, and then tune into the next video, which will help us divide matrices. Thank you for watching.